Hi, welcome back. We're going to continue our discussion with Taylor series. So in the last video, we really kind of talked about the sine function and how we can use it to approximate values with an error of less than 1 over 1,000. So don't forget we were using that alternating series remainder, and anytime you use that alternating series remainder, you got to write out our little mantra: the series alternates, decreases in magnitude, and the limit equals 0. So you got to use all of that stuff right here. And we even did use as an antiderivative. So remember, we couldn't do sine of x squared, so we had to use our Taylor series to approximate it. And we had an error of, like, what's that? Look at this. 0.0074 is our error. Crazy accurate. All right, so for the next example, we're going to look at the sine of e to the x. So for the first question, it says, write the equation for e to the x and give the first 4 non-zero terms and the general term. Now what we're going to do here is we are going to show you, as we do this one, I'm going to show you how the AP would grade this. So for the first part, they would say give the first 4 terms. And that should be pretty easy to do. So we should remember this from yesterday. This is just going to become 1 plus x squared over 2 factorial plus x cubed over 3 factorial. So the AP on a question like this, they would give you plus 1, maybe 2 points for the first 4 non-zero terms, 1, 2, 3, 4. But they want the general term as well. So to get the general term, we're going to go a little bit further. We're going to go plus dot dot dot. Now remember, the plus dot 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 means it's going to continue going on, and then plus, and now we're going to write our general term. And you can derive it yourself if you want to. This is just going to be x to the 0, x to the first, x to the second, x cubed. So this is going to become x to the n on top. And on bottom, notice 0 factorial, 1 factorial, 2 factorial, 3 factorial. Remember, we're typically going to start at n equals 0. So this is over n factorial. And this does go on forever, so don't forget to put the plus dot dot dot. Now how will the AP score this? They would typically give you 1 point for this question right here. But if you don't have the plus dot dot dot, they're not going to give it for you. Now the other option you could have is you could say the summation of n equals 0 to infinity of x to the n over n factorial equals 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot dot dot. Either one of these is acceptable, but I do tend to find people tend to like this notation better. It's a little easier to read than having to figure out sigma notation again. So I'm going to stick with this one. Now, let's talk about the scoring again. Now, remember, on the AP for the series question is typically scored very low, but the bulk of the scores you can get are from the very beginning. This would be like an A-level question right here. So this is already 3 out of 9 points, which is thumbs up good. All right, we are going to use this to approximate this limit. Now, we've done this one before, you might remember. They're telling us to find the limit, but they want us to use our series to get the answer here. So normally we would just use our, you would use L'Hopital's right here, but they want me to use the series, so we'll go ahead and use that. And this becomes e to the x minus 1 over 2x. So our rule, we're just going to substitute all this in. This becomes the limit as x goes to 0, 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot dot dot, and then minus 1. Now note over 2x. Now notice, of course, the 1's are going to cancel, and anything left in here I can factor out an x. So we're going to get this, the limit as x goes to 0. If I factor out the x, that's going to give me 1 plus x over 2 factorial plus x squared over 3 factorial plus dot 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 over 2x. And notice the x's here are just going to cancel out, which is nice. And that can factor out the 1/2, and we get the limit as x goes to 0 of just 1 plus x over 2 factorial plus x squared over 3 factorial plus dot dot dot. And notice every single one of these x's forever and ever and ever all going to go to 0, and what we're left with is just 1/2 times 1, which is just the half. So this is approaching 1/2. And of course, if this was any other question, you just use L'Hopital's and get the answer right away. But this isn't L'Hopital, so we don't do that here. All right. So let's see here. The last one. Okay, the last one. Okay, now this is where the fun begins for the AP right here. It says, write the first 4 non-zero terms for the Maclaurin series, e to the x cosine of x. And again, this is on the AP. So the first thing we can do is write out the first 4 for e to the x. Now it does say series, so don't forget that plus dot dot dot. And they don't ask us for the general term, so that's generally pretty nice. All right, so for when I write this out, e to the x, 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot dot dot. Now again, they don't ask me for the general term, so we don't need it, but I'm going to go ahead and write it because it's kind of fun to write. X to the n over n factorial plus dot dot dot. It's always good practice. Cosine of x, remember cosine is an even function. So it's like x to the 0, which is just 1, minus x squared over 2 factorial, plus x to the 4th over 4 factorial. See, it's the even. Cosine is even when you look at it graphically, so it's going to have all the even numbers. Minus x to the 6 over 6 factorial. And again, they're not asking for the general term, but I'm going to go ahead and write it anyways. Negative 1 to the n, it is alternating. X to the 2n over 2n factorial plus dot dot dot. Don't forget the plus dot 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 at the end. All right, so how will the AP grade these? They will give you a point here and a point here. 1 point for each one of those. Now next, they want me to multiply them. Okay, e to the x times, whoops, that's terrible. E to the x times cosine of x. So I'm going to go and do that. E to the x, whoops, which we said was 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot 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 times cosine, which is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus dot dot dot. Now we only want the first 4 non-zero terms. Be careful of your powers here. And on the AP, just knowing to multiply these out, they're going to give you a point. Look at this. They're going to. You already got 3 points on this. 6 points if about 6 or 5 or 6 points if you include this. So it's not hard to get really well. We don't even have the answer. We already got like 5 or 6 out of the 9 points. And you'd probably get like about 1 or 2 points out of a question like this one on the AP. So when we multiply, we are going to distribute here. So that's what we're going to do. So we're going to get 1 plus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus, go to the next one, x minus, this becomes x cubed over 2 factorial plus x to the 5th over 4 factorial. And I can actually stop there. If I want to go with the first 4 non-zero terms, there's 1, 0, 2, 3. I really only have to go out to the 4th degree. But I do got to go a little bit further. I do have to do this one. So I can go to this one now. Plus x squared over 2 factorial minus x to the 4th over 2 factorial times 2 factorial. And then I got to do this x cubed one. I don't have to go past degree of 4 because I'm looking for only 4 terms. Do the cubes. X cubed over 3 factorial minus, and that's x to the 6 over 3 factorial, 2 factorial. I don't need those. Those are too big. 5 is too big. 6 is too big. And plus dot dot dot. And you can leave it like this. If you're good, you would know my first 4 non-zero terms would have to be like 1, x to the 0, x to the 1st, x squared, and my x cubed terms actually. So I really don't even need my 4th degree ones right here. So I really only need all of these that are left over. And you can leave your answer like this, or you can combine the right terms if you like. Hope you enjoyed the video. I will see you all later. Bye-bye.